Good morning, all, and thank you for joining us at Interface project financed by Horizon 2020 Flexibility Solutions webinar. I'm Norela Constantinescu. I'm Research and Innovation Manager with ENTSO-E. And from ENTSO-E side, I welcome you to this webinar. I will start by actually making you aware about the rules of this webinar. So the question and answers will be dealt with through Slido. So you have here the link to the Slido, and then the code you have to enter, INTER with double R. Please post your question in the Slido. You can also vote there for your favorite question, and the most voted questions will be taken at the end of the session, 11 o'clock, when we have the question and answer session. So please do not use the question and chat in GoToWebinar, but in Slido. The rules of housekeeping. So I will ask the presenters to turn off their mic and video during the webinar so they can turn on when they speak. I mentioned the question and comments should be made in Slido. Again, the code is INTER for those who join us later. And we will take these questions and answers in the Q&A session, which is foreseen at 11 o'clock. However, due to the fact that some speakers might leave a little bit in advance, I will try to accommodate particular questions during their presentation. And with this, I would like to give the floor to the project coordinator, Mr. George Bultadakis from European Dynamics, to welcome you from his side as well and to introduce you the agenda. George, the floor is yours.
So thank you, Norela. So good morning to one and all present here. It is indeed my pleasure to welcome all of you, all the participants today to our first Interface Annual Flexibility Solutions webinar. I would like to welcome all the eminent speakers and guests from all over Europe, representing different fields of expertise of the European energy system. So this is the first event that aims to bring different stakeholders together in the history of Interface. This time, unfortunately, it is conducted through a digital platform in line, of course, with the social distancing norms due to the COVID-19 pandemic. But we hope that the next events will be physical and will allow for our effective interaction. So the theme of this event is the facilitation of flexibility in the European framework, and therefore we would like to present the Interface vision towards this direction, but also to learn from our invited experts what are their thoughts, their knowledge stemming from their vast experience from across the field. I would like to present shortly the agenda. So we have two sessions. The first session that starts now until the coffee break will include introductory speeches from representatives of INEA and DG Energy, also from the President of the Regulatory Authority of Energy in Greece, and then we will have a session where the interface different activities, the interface project different activities will be demonstrated. And after the coffee break, we have an invited speaker session where we will have an overall, let's say, overview of the work of the activity for the harmonized electricity market roles model, and also the experience and knowledge from other projects of Horizon 2020. So I would like to conclude my speech by encouraging everyone to participate in the conversations and share their view and comments during the dedicated sessions and through the provided IT tools as Norela presented. I wish everyone a successful and fruitful webinar. Thank you all again for your attention. So, Noella, back to you.
Thank you, George. So we will start now by actually addressing the European perspective, and we will have together with us, I hope, 3 representatives of the European Commission. So the first one to speak, it's Andrea Feltrin from INEA, so the executive agency which is in charge with managing the projects, Horizon 2020 projects, to which Interface belong. Andrea, if you are with us, please join me with your video.
Can you hear me?
Yes, I can hear you. I can hear you.
Sorry, I had to join by phone because I could not join through the other channel, so I cannot put up my image, my video. But if you can hear me, then I will just make a brief introduction and trying to recall a little bit what was the motivation from our side to fund projects, a project like Interface. So the background is, of course, the clean energy for our Europeans package, where it was identified that one need that had to be addressed was how to use flexibility in an effective way and in an efficient manner. Flexibility that is not only available at the transmission level, but also at the distribution level, and therefore how to coordinate the use of this flexibility between the system operators that are operating at the distribution level and at the transmission level. So Interface is one of the projects that are exploring this and are trying to find efficient ways to exploit the flexibility that comes from renewable energy sources that are connected at distribution and transmission level, and storage as well as other sources of flexibility like demand and response. Other projects have also been funded under this, let's say, general theme, and they are present here today, like Coordinate, OneNet, or EU SysFlex. So it will be interesting to see what kind of solutions they are working on, how they compare to each other, and to see how they, let's say, integrate also each other. And a particularly interesting development, in my opinion, is the, let's say, the intention of the 2 projects, Coordinate and Interface, to draft a common position paper on this topic. And I believe that at the last clustering event that we organized at the end of 2020, also OneNet expressed an interest to participate to the drafting of this position paper. So we are following with particular interest this development, and I think this event is also an opportunity to strengthen the let's say the collaboration and the coordination between these projects. This said, I would like to leave the floor to my colleagues, who I hope are also connected, Julia and Sabine, who will give a more, let's say, policy perspective around this topic. So, thank you.
Thank you, Andrea, for joining us. You can ask the questions to Andrea in the Slido, as I mentioned in the beginning of the webinar. And now we move to Sabine Krom from DG Energy. So we will see now more the policy perspective. Sabine is working with the unit internal energy market. So Sabine, please go ahead.
Yes, hello. So thanks for inviting me, having me here. Indeed, I work more on the regulatory side and the legislation we do in DG Energy regards to the electricity markets in particular. So I will give you a short overview, a policy perspective. I think Andrea already gave you a little bit. Well, to start on a very high level, I think we all know that the energy transition and the decarbonization ambitions, they will bring profound changes to the energy system and the way we produce, transport and consume energy. And this will, of course, also bring profound changes to the electricity system. So I think in the context of today, I would highlight in particular two important developments that are relevant. This is that we expect to see a strong increase in electrification of end users, such as transport, heating and cooling industry and industry sectors. So because electrification is seen to play an important role if we want to reach climate neutrality. Of course, this increased electrification also it can bring flexibility to the system if the demand of these end users can be modified. Second important development is that we will see a larger and larger share of variable renewable electricity generation. So it will be variable, but it also will be distributed, more connected at the distribution level and not only at the transmission level, how it used to be in the past for the big generators. So this all will have, of course, an important impact on the electricity system. It will change how it functions. And giving this, the increased demand for electricity and the variable distribution connected electricity generation will mean that we will need much more flexibility in the system if we want to keep cost limited and avoid, well, we cannot avoid fully, but to limit costly grid expansions. So this, I think, well, it's the Commission policy or the established policy that we need to tap all sources of flexibility, in particular also demand side flexibility. And I think that's what we are looking at a bit today. So as already mentioned, maybe some recent legislative changes. Important step was, of course, the Clean Energy Package adopted in 2019, which included a recast of the Electricity Directive and the Electricity Regulation. And the Clean Energy Package, as already mentioned by Andrea, it recognizes the increased need for flexibility in the electricity system. So we think that the package and the vision of the Electricity Directive in particular it's our big step to bring more flexibility to the electricity markets, and the directive contains a number of important provisions in this aspect. The Clean Energy Package also puts the consumer at the center. This, I think, is very important as well to have in mind, because it's the consumer will have an essential role for achieving the flexibility that we will need from the demand side. So some provisions of the Clean Energy Package I would like to highlight in this context is, which are important, is that there's the access of demand response to all electricity markets has to be ensured. Then the Clean Energy Package also contains the right of final consumers to participate in demand response schemes. The Electricity Directive also sets up provisions for a framework for aggregators, and it also establishes the right for every individual customer to contract with the aggregator independent of the agreement of its supplier. And finally, from the system side, the Clean Energy Package also contains provisions to increase the flexibility on the network side and to support the active management by distribution system operators, and to give them incentives to procure flexibility in order to manage their networks. I think, as also already mentioned by Andrea, well, this all means that the cooperation between TSOs and DSOs will become more important, because the developments I just highlighted will mean that the distribution system operators, they will need to manage their networks more actively because of the decentralized production, which is connected at their level, but also because of the new loads in place coming from the electrification of end users. So cooperation here will become more important because the actions, of course, by both can mutually affect each other and can cause issues in their respective grids. The Clean Energy Package also recognizes this and enhances the role of the distribution system operators in the European institutional framework. It strengthens the cooperation between TSOs and establishes the EU DSO entity. Well, it's a bit the equivalent, if one want to say so, to what we already have on the TSO side with ENTSO-E. So that's the EU DSO entity, which is currently being set up and which might become operational in April, May this year. So what's next from our side? It's of course the transposition of the electricity directive. While the electricity regulation already entered into force and is directly applicable, of course the directive will need to be transposed. Deadline for this was the end of the year, but of course the process to follow this transposition is still ongoing or only just starting now. So it will be very important to see how, in fact, the provisions, the new provisions around demand-side flexibility and aggregators are transposed and practiced by the member states. Well, what's next is that the Commission is planning to do work on a network code for demand-side flexibility. So such a network code is supposed to address like remaining regulatory barriers for the participation of demand-side flexibility in electricity markets. But in particular, it's also supposed to look at how a local congestion market might be created where demand-side flexibility could be procured by DSOs to solve congestion at peak times in their markets. So there, well, works have not really started yet. I expect them to start in the second half of this year with first informal steps. So the work, it will either be like discussions around a new network code for demand-side flexibility or amendments of existing network codes and the guidelines like electricity market balancing guidelines, system operating guidelines, etc. So there no final decision is taken yet. If you're more interested to know a bit what issues might be addressed there, I invite you to look at a study which the Commission did in last year, which was published in November 2020, in fact, under the asset framework, which is also managed by our colleagues in V5, from which we have Julia here. And it's a study which is called Regulatory Priorities for Enabling Demand-Side Flexibility, and it looks at regulatory gaps for the development of demand-side flexibility. So you can find much more detailed information there. Well, so that's what I have for the moment. So I will hand back to Norela or hand over to my colleague. Thanks.
Thank you very much, Sabina, for giving us this regulatory perspective to which we hope that the projects like Interface will contribute, especially from a flexibility point of view, and of course for the new coordination schemes between TSOs and DSOs, which we try to test for different services, products, markets. I will pass now the floor to Julia Serra, which is she's coming from Research, Innovation, Digitalization, and Competitiveness unit. So to give us also the perspective from more innovation side. And I would like to recall, please post your questions in Slido with the code INTER with double R. Thank you. Julia?
Yeah, good morning, everyone. Unfortunately, my connection is not so good, so I'm not able to turn on my video. So first of all, thank you for indeed inviting us. My colleagues already provided a very complete overview on what's going on at European level in the European framework and like the different policy aspects related to flexibility. I would like to take a few minutes to let you know about indeed new activities that are now going on and planned within the Commission. We heard from my colleagues that indeed we have a lot of planning ongoing activities, actions, revisions, implementing delegated acts that have to be follow up and have to be implemented. So here is really key for this year to come and for the next year to come to make sure we make use of complementarities among the different tools and the different instruments that we have available. And so we need to focus our efforts and working together towards the achievement of a common goal, this twin transition that is at the same time sustainable, green, and also digital. Therefore, and this is also very much linked also to the flexibility topic that my colleagues covered, we are currently working on the digitalization of energy action plan. It's an action plan that has been proposed in the energy system integration strategy as one of the key actions to accelerate the implementation of digital solutions. Such action plan will build on the common European energy data space that is one of the 9 common European data space described in the communication on European strategy data that we published last week, but will also contribute indeed to the implementation of the clean energy package that is indeed a key pillar for a digitalized energy system with citizen at the center, and will also be indeed in line with the communication on Europe's digital decade, thus achieving the objective of contributing in achieving the objective of a twin transition. The action plan aims, so on one side, to contribute to the European energy policy objective by supporting, as a final scope, the development of a sustainable, cyber-secure, transparent, and competitive market for digital energy services, ensuring data privacy, supporting investment in digital energy infrastructure, and creating a positive experience for the end users and for citizens. And given the importance of digitalization for a flexible electricity system and the growing electrification that is needed to reach the 2050 climate and energy objective, the action plan will primarily focus on electricity, while also addressing eventually other energy carriers such as gas, heat and cold, at least from an energy system integration perspective. Thus, I would say the key areas that we want to focus on and we would like to investigate also with supports and experience gathered from different projects are, like, we identified 5 main areas. First of all, facilitating interoperability of energy data, platforms and services. Second, enhancing the uptake of digital solutions in the energy sector. Empowering citizens, ensuring cybersecurity, reducing the energy consumption of ICT, meaning focusing not only on the opportunities coming from uptaking digital technologies and bringing them in the energy sector, but also focusing on the challenges that the digitalization of energy is bringing to the system. So very briefly, of course, as my colleague said, having citizens at the center. We need to develop tools to support citizen engagements in the energy market. We need to ensure that we design a data-driven energy services market that has consumers' benefits and right and its core. And we also need to pay attention to address concerns related to energy poverty issue and digital divide. We need to enhance the uptake of digital technologies in the energy sector. And here the dimension of research, innovation and development indeed plays a huge role. We need to accelerate the development, implementation and upscaling of digital solutions in both the energy supply and demand sectors. We need to support the energy transition as well the competitiveness of the European industry. What does it mean? It means that on one side, we need to indeed mobilize research and foster innovation, but we also need to actively push for the development and testing of IT technologies in the energy sector. And at the same time, we need, of course, to create the demand for such technologies. And we need to enable a proper market. Plenty of solutions have already been developed. And now, as I mentioned before, and actually as it evidenced from what my colleague said, we really need to count on the complementarities of the different instruments that we have available and the different programs that we now have available and we are implementing to make it happen. Concerning the challenges, as I mentioned, We need to address the growing energy consumption of the ICT sector. At the same time, we need to secure the energy sector, and we need to address the challenges related to the specificity of the energy sector, meaning like ensuring cybersecurity, focusing on the energy sector itself. And this will be done, as an example, through the forthcoming network code on cybersecurity under the electricity regulation. And the last area that I would like to focus on, last but not least, is that indeed, above all, as we mentioned, the digitalization of energy sector will have to support and enable the development of a data-driven energy services market that is able to value flexibility of the energy system, meaning demand response, smart charging, integration of renewables, distributed energy resources, and so on, and thereby helping the integration of renewables in the grid, while at the same time providing better services to the consumers. So to conclude, of course, one of the objective of this action plan, in order to enable the creation of such a market, is the development of a European digital data infrastructure that facilitates data exchange at appliance level and among different players along the energy value chain. And how do we intend to do so? And also why we would like your feedback and your support. We really need to work on complementarities and synergies. We need to collect data from the field. We need to have all the actors actively engaged in this process. So our work will only succeed if we act at European scale to enable a data exchange. We need to involve as many sectors and as innovators as possible. We need to involve all the regulators, the network operators. So this is also why maybe the discussion of today can bring us additional input on what are the points that require our attention and could be considered for the specific action plan. And here, yeah, I close and I pass the floor once again to Norella.
Thank you very much, Giulia, for complementing what Andrea and Sabina were saying by looking a little bit into the future and by indicating the directions on which, from research and innovation side, we can move on. Before passing the floor to Athanasios, I would like to once again recall you, please do not put your questions in the question and chat of GoToWebinar, but use Slido, and you will have actually in the chat the link to the Slido. So thank you for following that. It's a little bit easier and it's more attractive actually to look at other questions and to exchange faster. So with this, I will pass now the floor to Athanasios Dagoumas, the President of Regulatory Authority for Energy in Greece. We are very pleased to have you with us here today, Athanasios, especially because you were some time ago directly involved in the Interface project. So the floor is yours now.
Thank you, Norella. It's also my pleasure and my honor to be in this event. Over the last 6 months, I have been enrolled as President of the Regulatory Authority of Energy Greece, but my involvement in the Interface project helped me a lot to also to my new role, so I will explain how this is takes place. I have a presentation that I will show you some developments on the Greek electricity market. Our market, to be frank, is not of the most mature in Europe, but we have done some important developments over the last period and how we see flexibility markets involved in it, and we would like to have an important and dynamic role in the formation of the European markets. So, could you please change to the new slide? Okay, so practically, until November, we had a NOR model, a unit commitment model based on the PJM market in the state. So it was a co-optimization model of energy and ancillary services with some regulatory restrictions on the bidding, which had to be changed some years ago. There was a delay within Greece, but we managed to do it. So we made 62 regulatory decisions within a few months in order to transit to the new target model. So please to the next slide. in the new model, we have also made an important step. We made the market coupling with Italy in December, so within 1 month, and in a few months we'll do the market coupling with Bulgaria. So we have already made some progress within target model. But of course, we have a lot of things to do. We plan to integrate, of course, our model to the XBit platform. This is to be done in a few months, in about 1 year, and subsequently to the Mari and Picasso platforms. The regulator is strongly committed to facilitate this transition, and they will do it as much as we can in order to be one of the most active players in the region, and this is how we view our role. So, please, next slide. Over the operation of the electricity market, just some slides what is happening. The most important thing, this is the day-ahead market in the 3 months from November up to January 2021. What I would like to point out, note the mix, etc., and the evolution of the price, is that you can see in the bottom line that we have also a limited role of lignite, because our government is strongly committed to the full delignitization in the next 2 years. So our energy mix will totally change in the upcoming months. So this is something that we have to take in the market design that we elaborate. So please, next slide. What is also important to mention is that the monthly day-ahead price in Greece has been for the first time below the European average in January 2020. So in some sense, we see that we have a market coupling process. However, in the balancing market, we have some concerns. That's why we have intervened in the operation, where we made some first regulatory decisions, and we have a strong cooperation with the TSO in order to elaborate some market design issues. So we plan to make some decisions that concern also redispatch and congestion management. And this is what we would like to focus in the next slides, which is strongly related with the work that we have already done within the Interface project. So please, next slide. So during this period, we have explored the possibility of cooperation with many regulators. The same is also happening with the TSO, with many system operators, and we have defined that the congestion management and the redispatching is a major issue among many European regulators and the TSOs, especially on the flagging of the redispatch as well as their enumeration. There is no common approach. There is different approaches that are market-based or cost-based approaches. We are considering all of them with strong cooperation with the TSO. Of course, among others, what we examine is the TSO-DSO report on the integrated approach of the active system management, the ASM reports. This is something that is the core in our approach, how to proceed on, but also the Interface project output as well as other outputs. But we also see not only European markets, but as well other markets in the USA, because as you see in these periods, there is a lot of problems in the Texas market. So we see what are the messages from the operation. In any case, the decision making that has to be taken by then on market design has to concern all the basic market design characteristics, zonal or nodal. We don't have nodal system in Europe, at least for the time being. In Greece, we have a unit-based and not portfolio-based, to see how we can have separate or mixed market order list for congestion management or not, and how to see, to be pragmatic, what can be done by the TSO in the medium term, in the long term, in order to have a smooth transition to the new markets and to the new platforms. So please, next slide. So in order to do so, we have to see our, please, next slide. This is a very informative scheme, and no, please, the previous one. This is a very informative scheme that is part of the Interface project on delivery 2.4. It was prepared by Florence School, if I remember correctly. So it shows the market design in different countries. Our now focus is on number 4 on transmission and dispatch. For the time being, this is integrated in the integrated scheduling process within the balancing market. We'll see how we can identify those issues on the limits as well on the optimization of those issues. But we also see other market design approaches, for example, establishing like 3 on a separate balancing capacity markets that are the link from the integrated system scheduling process. So we are considering different approaches that exist in Europe in different countries. So please, next slide. The most important issue, of course, is in order to be pragmatic, to see what is the situation in our country. So the situation in our country, of course, as you can see from this slide, from the ENTSO-E report, is that there are a few countries that have a unit-based central dispatch regime, as is in the case in Greece. So we have a strong cooperation with all these countries in order to see what they are applied in their regime, in order to be able to have some best practice if they have something to provide to us, or we might find a solution that might be good for their system too. So please, next slide. So of course, we are strongly committed on applying the European regulation. I have 3 slides on the European regulation. So, for example, the regulation 2019/94/3 discusses about the dispatch. The dispatch is being defined that's concerned with physical possession as well as on ensuring system security. But also, please, next slide, at the same time, the same regulation and another article identifies that in case of resource adequacy, like what's happening also now in Greece because of the rapid delignification, we have to consider shortage pricing functions, so scarcity pricing options for the balancing energy, cost efficient and market-based procurement for balancing and ancillary services. So this is in our skeptical approach, and we are coordinating with the TSO for this. But we also consider, the next slide, please, the ACER decision concerning the system constraints, which goes in more detail on what is defined as system constraints that is being elaborated by the TSO, that concerns not only voltage limits and power flow limits, but also reactive and active power reserves and system margin. So all this information has to be incorporated in our approach. And please, next slide, which is then the final one. We have to consider all this approach in our decision making on how to capture information. For example, the ASM report. On the ASM report, there's a clear message that in unit-based regimes, we can have merit order list for congestion management and balancing, and some of these bits can be skipped in order if they are applied for congestion management. And please, next slide is the last one. So we also incorporated the material that's used from the interface project from the ASM report. This is an important input that is being used in the interface project. So how to consider the different merit order lists for congestion management at the ESO level. We want to consider, based on our unit-based approach, that we could have merge or not separate congestion management and dispatch orders with the balancing orders. Of course, they have to provide robust pricing, scarce pricing. We have to enhance competition, demand participation, which is the core of the European policy, and in order to attract flexible assets. So all these considerations are being in our approach, and soon we'll have some developments to announce officially with a strong cooperation with the TSO. And the final slide, please. So we think and we hope that the Hellenic Energy Regulator will be useful to the market design of the European markets. And thank you for your attention and for the invitation to your event. Thanks.
Thank you very much, Athanasios, for showing us the regulatory perspective you took in Greece. And we are happy, of course, to see that actually the interface project and also the cooperation we established between the TSOs and the DSOs through active system management report was can serve as an input to the work you are doing in Greece. Before going to you, George, I would like to have two questions which are raised for the representatives of the European Commission. So afterwards, we will step in the details of the interface project. So if Sabina and Julia are still with us, in the Slido, there are two questions. One regarding it's for Sabina, I think, so it's my colleague Victor, asking actually the distributed system flexibility code. So if you, when this is going to be developed, so how you will take into account the projects which were financed already by the Horizon 2020, and if you still see some unsolved issues. Sabine?
Yes, I'm here. Just have to click. Well, I can switch on. So it was. I was making some notes. So as regards the question of Victor, I think at this stage I'm not able to point him to any particular projects. Of course, the units in charge of the different things like us for the network code and the ones more in charge on the research innovation side, we are in contact with each other. But at this stage of the process, which is also still very early, I would not be able to give some details on this. But of course, it's something also we will look into. Yeah.
A second question which is coming, it's mainly related to data gathering and the fact that we have quite a lot of projects. So it's more related to the Danish DSO in the island of Bornholm. Maybe for Julia. Julia, still around?
Yes, I'm here. I didn't find the button to unmute myself. I'm sorry. So I'm reading once again the question.
So how the flexibility can help the DSO in the island of Bornholm? This is a particular case, I think, which was taken in.
Yeah, actually, I mean, if I can just thinking out loud, indeed, data gathering and sharing is something that, I mean, is one of the key challenges we are facing right now. It's something that, of course, is not that we realize it today, but is a challenge that we are trying to overcome for sometimes now, because otherwise creating a data-driven energy services market will not be possible. We want indeed to, so one of the key areas of the action plan is indeed to try to develop a European digital data infrastructure. The digitalization of energy action plan will actually concretely be a set of actions for each of the 5 areas that we are now reflecting on. And indeed, one of the first steps would be to try to identify how to make it possible. So what are the enabling factors, not only like technological enabling factors, but also addressing the challenges related to the social dimensions, to the data management, to the different players to have to involve, and concerning like data gathering and data sharing, actually what we are trying to do, and this is something that will happen during the BRIC General Assembly that is taking place next week. I think you are very well aware of it, but we can of course share more information and details. Indeed, we are really trying to bring all the projects together, reflecting on how to overcome this specific challenge. How can we gather data? How we can share data? What are the enabling factors? What kind of data we need to share? What are the challenges? What are the barriers? And indeed, one of the scope of, I would say the final scope of the BRIC General Assembly, if I can make an example, is indeed having projects working together to overcome such specific challenges, thus consolidating synergies. We really count on projects to overcome this, to find a solution and to find concrete actions that can be implemented, that can be followed up. Because indeed we recognize is an extremely difficult challenge to overcome and is a precondition for a digitalized energy market.
Thank you very much, Julia. I think for the sake of time, because we have quite packed agenda, so I would move now to George Bultarakis, the project coordinator of Interface. So George, now we deep dive in Interface project, and keep continuing posting your questions in Slido.
Okay. Thank you, Norella. So next slide, please. Actually, Interface answered, of course, as it was also mentioned by Norella at the beginning, has received funding from Horizon 2020, the research program of the European Union. It answered the specific call on the TSO-DSO consumer, large-scale demonstrations of innovative grid services through demand response, storage, and small-scale generation. And the full title of Interface is the TSO-DSO Consumer Interface Architecture to provide innovative grid services for an efficient power system. So the duration of this project is 4 years. It has started its works in January of 2019. So we are more than 2 years old. So next slide, please. So Interface brings together 42 partners from 16 different countries. It is a heavily industry-driven project, having on board 7 transmission system operators, 8 distribution system operators, ENTSO-E, the European Association of TSOs, energy suppliers, aggregators, 1 regulator, 1 market operator, and many research organizations and service and technology providers, and also the Florence School of Regulation, which is an international organization. Next slide, please. So how the concept behind the Interface was born. So the vision was to, first of all, to remove the barriers in the European power system, and in this manner to unleash the potential of existing and future resources to be an active part of the power system. Of course, this for the benefit of the customers and the grid operators. Also, our vision included the coordination through digitalization, and to demonstrate in this manner at the large scale how markets and platforms can enable system and market operators and the energy flexibility providers to connect and procure energy services. Also, we wanted to increase transparency and interoperability by proposing common concepts that would be, let's say, applicable to the whole of Europe. Our intention again was to bring the consumer to the center, to combine local and congestion management markets with wholesale and balancing markets, and in this way to increase cost efficiency in the operations of networks, and also to create benefits for the consumer. And finally, we wanted to create new business opportunities to promote the works of innovators, to empower new participants in the electricity sector. So after all this, let's say, introduction, the strategic objective of Interface became the design of a common architecture that would connect all these different actors and markets in a transparent and non-discriminatory manner. And this, of course, would imply that an effort in order to drive collaboration in the procurement of grid services should happen. Also, the integration of small and large-scale assets in order to increase liquidity of the market for grid services. The definition and demonstration of standardized products and the activation and settlement process for energy services, and also the adoption and promotion of state-of-the-art digital technologies in order to engage end users into the next generation electricity market transaction. Next slide, please. So this is what we call the Interface product. This is, of course, a conceptual graphics that shows the core in the vision of the Interface project, which is to deliver what we call an interoperable pan-European grid services architecture, and of course its IT implementation, in order to serve the needs of the participating stakeholders and, of course, the participating demonstrators. So you can see on the left-hand side, the different actors, the assets they possess, the market models, the services, the data they currently exploit. In between lies EEXA, this, let's say, interoperable architecture that connects existing services, business models, coordination schemes with new incentive-based marketplaces and services. This open, let's say, architecture ensures that all customers have access to all markets and they optimally exploit their resources, their assets, their data sets. EEXA introduces novel coordination schemes between the actors, introduces new technologies, innovative technologies for the digitalization of the energy sector, and also in the core of this, a powerful data governance, let's say, tier lies in order to, let's say, facilitate this information sharing and data exchange needed. And on the right-hand side, you can see that interface incorporates new market services for 3 thematic areas, namely for congestion management, for peer-to-peer trading, and also for the integration of wholesale and retail market. So EEXA as a whole, I would say, is an open architecture that allows sharing data among all participants in the electricity system value chain from local, regional to EU level. And the vision is to enable the system operators and customers to coordinate their efforts and maximize the potential of their resources through a transparent market mechanism, and also allow the participation of more actors to favor smaller consumers and prosumers, and in this manner, let's say, to lead to the unlocking of an important flexibility potential. Next slide, please. So, of course, this is, let's say, a conceptual architecture of the EEXA. Many things will be given, more details will be given in the presentation to follow. Anyway, in order to design, let's say, the engineering blueprint of this open architecture, interface project adopted a hybrid approach, what we call a bottom-up and top-down design approach. So we wanted, on the one hand, to rely on this combination of approaches to take advantage of the expectations, of the specific needs of the demonstrators that are present in the interface project, and at the same time, to provide guidance based on the knowledge of our experts on lessons learned from the active system management report, from other EU projects, but also to follow the directives and the strategies of the European Commission. So a top-down analysis was firstly carried out in order to identify the relevant market and non-market services, and to develop a detailed classification on which services interface would implement. These services were described in further detail, taking into account and as the basis, let's say, the different market structures that have been investigated with the guidance of the Active System Management Report. So 4 main services have been selected according to the common objects of the different demonstrators, and these are balancing, which is carried out by means of automatic and manual frequency restoration reserve, and also congestion management, which is operated by means of both short-term and operational reserves. So based on the general requirements for the coordination of actions between the system operators and the other actors, we decomposed the core of the interface platform into different architectural components that are actually there to facilitate the full life cycle of a product definition and design and procurement. So these components, and as I said, more details will follow, are the flexibility register, which is according to a recommendation of the Active System Management Report on the usage of a flexibility resources register for a coordinated, efficient, and secure active system management process. And this register actually gathers and shares all relevant information on potential sources of flexibility. So we think that this module actually serves the European vision of interface for interoperability, as it enables the seamless connection of flexibility service provider to bring the flexibility products to markets. Moreover, another architectural component is the TSO-DSO coordination platform that actually acts as the gateway through which the operators can access the EXA platform, and it allows the data exchange between operators and facilitates their coordination of actions. Another component is the single interface to market, which is a gateway, a point of connection of the EXA platform to other market platforms, and it communicates the flexibility needs of the operators to the market. And finally, the settlement unit, which is responsible for calculating, of course, the settlement and publish the settlement results to the market. So, as I already mentioned at the beginning, we also try to set the basis to address data interoperability within this rather interdisciplinary and multinational environment. And we have spent great efforts to promote a systematic way to adopt international standards. And this activity has led to the design of a modular interoperable data governance tier. Next slide, please. So the interface demonstration trials will be executed in 3 main pillars with the aim, first of all, to mitigate congestions and active local flexibility resources for system balancing services through the EXA, operated in a coordinated manner by the system operators, to promote the integration of distributed energy resources into the electricity market and demonstrate mechanisms that lead to the establishment of a seamless pan-European market, and finally to test the state-of-the-art technologies such as blockchain for peer-to-peer energy transactions that promote local markets and smart asset management. Next slide, please. So these are, as you can see, the 3 demos of the first demo area, and we have a TSO and Consumer Alliance demo in Italy, and intelligent distribution nodes in Bulgaria, and the single flexibility platform demo in Finland, Estonia, and Latvia. Next slide, please. In the peer-to-peer trading demo area, we have the asset-enabled local markets in Hungary and Slovenia, and also a blockchain-based TSO-DSO flexibility in Bulgaria and Romania. Next slide, please. And finally, in the pan-EU clearing market demo area, we have the distributed energy resources into wholesale demo in Romania, Bulgaria, and Greece, and also a demo for the special aggregation of local flexibility in Romania. And with this slide, I would like to conclude. This was, let's say, some first information regarding the interface, and more things, of course, will follow. Thank you.
Thank you, George, for giving us an an overview of the interface project. So I continue to keep an eye on the Slido. So sorry, Julia will answer when she's coming back to one of the questions which was raised there. So now we go to Pierre Mann from Aachen University. Talking about the products and services we have about market and products we have looked upon in the interface project. So go ahead, Pierre, and yes, let's try to keep to that 10 minutes.
I give my best. Yes, thank you very much for the introduction, Rayla. Yeah, thank you very much that so many people have joined us today. That makes me very happy. I would like to discuss now interface solutions with respect to flexibility services, markets, and products, basically. As one of the work package leaders with in the interface project, I'm here today to present you those results. And to start with, I would like to give you a short overview of what we did and how we approached this task. Then I would like to provide a short introduction into markets that we took into account and that we have analyzed. Then the third point that I would like to cover today, I would like to give you an insight in the relation of the demonstration projects and markets that we have described and how the evaluation of these markets worked. And as the last point of today, I would like to provide a short conclusion and then a short outlook. So what remains to be done within the interface project on this matter. So you could go, just click twice. Yes, thank you very much. Starting with the objective and approach, what you can see here on this slide is our approach. What we wanted to do is to develop market designs for the procurement of specific services in order to derive necessary aspects of the EXA infrastructure, which was just presented by George. For this purpose, we have derived a two-step approach, which basically consists of two major phases. The first one is to identify the relevant markets, and then the second phase is to, after the definition of the market, to evaluate and amend the market design so that in the end we conclude with one final market design. Looking into a little bit more of detail, so this identification and definition of this market design followed based on this top-down, bottom-up approach that George has just indicated. So based on literal research as well as alignment of the demonstrators, other pilot projects, and so on, we try to define which markets are relevant in this project. We developed their definitions and the market design for those markets. And now in the process that we are currently in, we try to evaluate if these developments that we made are suitable, and probably we can further amend these designs that we came up with. So therefore, we are currently presenting intermediate results. So if there are any major updates, of course, they will follow afterwards. But in the moment, it looks like we did quite a good job, and the demonstrators at least seem to be quite happy with the definitions we made. Could you go over to the next slide, please? Again. So as I said, we were starting with identifying relevant markets and products. So as I guess all of you are aware of, we see fundamental changes characterized by decarbonization, decentralization, digitalization, and democratization. With the implications of markets that we see here is on the one side that existing markets need to adapt to these changes. So meaning, for example, lower lead times and smaller product sizes and the ongoing harmonization. On the other side, we see potential new markets, and for these new markets, of course, the procurement of ancillary services is one of the often discussed topics here. And we figured out, or looking at pilot projects and the discussion in the research area, we figured out that especially congestion management markets are likely to be introduced, and the demonstrators are focusing on those markets as well. So these are basically the markets we would like to focus on in the project. And on the next slide, I will just give you a very short overview of which markets we derived. Generally speaking, we identified 3 different services which take into account the different uncertainties that result from the time where the planning process is in. What you can see here are then 3 different congestion management markets or services, which are long-term, short-term, and operational congestion management services. And if we think back about uncertainties, then for long-term congestion management, what you have in mind if you speak about this is, in order to tackle long-term maintenance work, for example, 3-4 months ahead, it might be already anticipated that congestions occur more often in a specific period in the future, so that you can always already start to reserve some flexibility for these periods. So this is what we understand as a long-term congestion management market. For short-term congestion management market, we are speaking about more the day-ahead time frame. Looking again at uncertainties, we see various uncertainties from power plant operation, renewable load forecast, and outages, and so on. And one specific point in time that we are identified when uncertainties are significantly reduced is after the nomination of the day-ahead schedules, when at least power plant operation is more or less clear. So, and only small adaptations to this occur. So at this point of time, we think that for the network operator, it is already possible to calculate quite accurately the demand for congestion management. And so at this very specific point in time, we located this short-term congestion management, which is an energy-only market, an energy-based market here. So that means that we foresee scheduled products here, whereas for long-term and operational congestion management, we see conditional products, meaning that we reserve capacity and then activate this capacity. Speaking about operational congestion management, this is basically, or the idea is to cover for very short-term uncertainties, so uncertainties close to real time, basically changes in the forecast of wind and PV or outages and so on. And to deal with those aspects, we have to procure flexibility in advance, and that is what we would like to do with the operational congestion management. Could you go over to the next slide, please? Here we see the different market options that we came up with. So if we speak about those markets, we have to structure them to derive different different market options, basically, or coordination schemes, and the Active ASM report did a quite good job here. We basically we went to a little bit higher level here again and put up some more options. So on the one side, you can see the level of TSO and DSO integration. So we can have markets that are TSO or DSO only, as well as markets which are a combined or fully integrated market. And the same is possible for the level of integration with other markets. So on one side, the congestion management markets could either be separated from existing markets or combined with other markets, either in way of a subset of the merit order lists or even fully integrated. And of course, this level of integration with other markets, especially, as well as the level of integration with TSO, DSOs, always promises lower complexity for the flexibility service provider. So if he has to take part in one market instead of multiple markets, so that is one huge benefit, as well as higher liquidity and expected lower prices there. If we so what we did now is that we try to figure out for each of these market options and markets which processes we would like to have to analyze. And if you can probably go to the next slide, please. There you can see the different processes: grid qualification, product qualification, service procurement, then the activation if necessary, and the settlement phase afterwards. So all these processes have been analyzed for each of the markets within our work package, and they are then going into this EXA platform that was already presented by George and will afterwards be presented in greater detail by our colleague Nicolas as well. I would like to go over to the evaluation of the markets and products. So what we can see here from the demonstrators, and I have indicated on this table here, on the one side, long-term, short-term, operational and local energy markets, and on the other hand side, you can see the demonstrators here that we have and that were already very briefly introduced by George. And what you can see here is that all of the different markets or congestion management markets that we figured out are tested by at least one of the demonstrators. So that showed us that there is a need for all of these congestion management markets. And yeah, what you can see furthermore is that DSOs, or at least the demonstrators who are focusing on DSOs, tend to use the operational markets, whereas the demonstrators focusing on TSOs tend to use short-term congestion management markets. Furthermore, I have two more slides speaking about a little bit more about the details about these markets and the market options. If you just quickly go over those. So to the next slide, for short-term congestion management markets, we can see that these market options where a high level of integration of markets of TSOs and DSOs is favorable, as well as a combination with other markets. And for operational congestion management, so if you could go over to the next slide, please. Sorry, yeah. For operational congestion management, we can see that most demonstrators now focused on DSO only markets. So it seems to be that these markets tend to be, yeah, for DSOs probably only, and a large interaction with TSOs might not be. So I would like to go over to the conclusions now. If you could go over. Exactly, thank you very much. So generally, we figured out that we we identified 3 different types of congestion management markets: long-term, short-term, and operational markets, with conditional and scheduled energy products, so conditional capacity products for long-term and operational, and scheduled energy products for short-term congestion management. And the first results show that the developed market designs will be tested by the demonstrators, and all of them are needed. Of course, further evaluation needs to be done in the next weeks and months, of course. And furthermore, we plan to do basically a simulation-based evaluation of these results until the end of this year. And of course, those results will be published then in the deliverables that you can find on the Interface homepage. So that's all from me. Thank you very much for the attention.
Thank you very much, Pierre, for this deep dive in projects and the market of Interface, which we looked upon. So I will take the questions at the end of all the session. So I will go now directly to Nikos Bilidis, coming also from European Dynamics. So Nikos, please go ahead and explain us about how IEGZA is working. And please keep 10 minutes if possible. You are muted, Nikos. No, we cannot hear you. Nikos? No. Unmute your mic, or can I ask Laurent to unmute the mic of Nikos? Nikos, can you try again? If not, then we jump to Milan. Nikos, try again. No, it doesn't. It doesn't work. Now,
working?
yes. Yeah, now
Okay.
it's working. So go ahead.
It appeared that I was unmuted. I don't know why this happened. Anyway, sorry for this. My name is Nikos Bilidis, and I'm an R&D project manager in European Dynamics. I'm going to give a short overview of the EXA platform, which is the main product of Interface project, and we'll bring together all the demos and all the applications that will be developed through the course of the project. So EXA stands for an interoperable pan-European grid service architecture, and is acting as an interface between connecting all energy value chain stakeholders, and connecting the operators and the consumers, and allowing the common procurement of services and coordination between the actors. So next slide, please. As I said, we are talking about a common architecture which will enable the connection and the data and information exchange in a seamless manner, aiming to optimize all the operations of the different stakeholders, and to introduce standardized services and market designs, and to offer novel functionalities that so far were time consuming, to optimize those and to bring forward the digitalization of the power systems. So as it has already been described, we have EXA has 4 main modules. The flexibility register, which is the main component, and it acts as a centralized repository where all FSPs can register their resources, and the system operators can have an overview of the available flexibility capacity that they have in their hands in order to optimally manage and operate their networks. We have the TSO-DSO coordination platform, which is the gateway for the system operators to EXA, and which allows them to perform the various functionalities. A single interface to market, which is a set of APIs that allow the connection to different, and the integration to different markets, and the secure data exchange with the markets. And finally, the settlement unit, which is responsible for calculating settlement, the settlement of the trades that take place in the market. Those modules can run independently within EXA, but also can be they're modular, so they can be complemented with other additional automated services. Next slide, please. So here we can see an overview of the EXA architecture, which is based on the SGAM framework. You can see the 5 layers of SGAM. On top, we have the business layer, which is actually comprised by the actors and by the main business use case of the platform, let's say, the main functionalities, which are namely the grid qualification, the product qualification, the procurement of services, the activation, and the settlement. So we cover the whole, let's say, market value chain. This facilitated by the function layer and the existence of the tools and the modules that I mentioned earlier. And one of the most important and core tasks was the development of the information layer, which is a very sophisticated data management middleware, which allows the data exchange between the different actors. We have implemented, let's say, role-based type of access, so that each user can only see data that are relevant to him and nothing more than what is allowed. We have used both some custom data exchanges, but also standardized data exchanges, and we are now in the position of trying to make all data exchanges standardized using mainly the common information model, as we aim towards a very scalable and replicable solution. And for the communication channels, we are using also REST APIs, but we intend to integrate with the connectivity platform of ENTSO-E, the EcoSP, which will allow us to securely connect all actors and exchange messages through encrypted and secure communication channels. This is something that is already being used by TSOs, and we want to extend it so that it covers, can be used by more roles. And finally, the component layer, which is, let's say, location specific, country specific, and application specific, which includes all the assets that are relevant for each one of the applications. Next slide, please. So we are happy to say also that we have prepared a first operating and functional version of the EXA platform. This will allow us to kickstart the activities of one of our demos in Estonia within this week. So we are ready to go live. And this first prototype, of course, will keep evolving as the project matures, but currently covers certain functionalities, such as allowing market operators to register product definitions, FSPs to register flexibility resources, to aggregate them and manage them into through resource groups. We support an automated resource qualification process under various circumstances where it is needed. The product qualification, and we have also developed elaborate trading processes for congestion management and MFRR products in Estonia currently, but of course this will be extended to support more products as the project matures. And we have implemented an automated bid qualification service and process of the trades. Next slide, please. So I have included some screenshots of the platform so that you get an idea of how it functions, since there was not enough time for a live demonstration. So we have a user management module where the administrator can manage the accounts, then control the users. Next slide, please. Then the FSPs can access the flexibility register, where, as I said, this acts as a pool of resources. They can register all their assets and manage them, aggregate them into resource groups, and participate in the market through these resource groups. Next slide, please. We offer also some kind of overview of the status of all the resource groups that the FSP manages with their respective grid and product qualification statuses. The FSP can also view their trades for the different days and for the different markets and product sessions. And we have some dedicated space for the market operators where they can input their product definitions and also control the product qualification requests. Next slide, please. So also moving on to the TSO-DSO coordination platform, the operators, the system operators can have an overview of the flexibility potential that stems from all the resources that are connected to their grids. This aids them into a more efficient grid operation and secure safe grid operation. We also offer the ability to system operators to view merit order lists for the various market sessions that run within the day. This can also be exported into standardized XML files following the SIM model. And the system operators also have the ability to activate bids through EXA. And this is communicated also to the markets to achieve synchronization of all systems. Next slide, please. Next one, sorry. And finally, the settlement unit, where the FSPs can have an overview of the settlement results about the bids that have already been settled. And through this user interface, they can download the results. So moving on to the final slide, I wanted to stress again the importance of the data middleware that we have developed and runs within EXA. This allows EXA to act as a data broker between the various actors that are being connected. It facilitates the communication and secure and seamless data exchange between actors. Of course, our main aim is to achieve a scalable and replicable solution, which will be applicable in many European countries, in all European countries, with little parameterization. So we want to achieve a plug-and-play solution. We are integrating to existing markets, to existing commercial markets, but also we are proposing new market designs and new standardized products, as Pierre presented earlier. And in order to enforce this scalability and replicability, we are using a standard, well-established standards. So we want to, we aim to achieve that all our communications are standardized using SIM or other well-established standards. And finally, we want to establish secure communication channels by using a combination of REST APIs and also taking advantage of the EcoSP platform of ENTSO-E. So that's all from me. Thank you.
Thank you very much, Nikos, and thank you for also keeping the time. So I will move now quickly to Milan Kostov, my colleague in ENTSO-E, talking about SIM. And I would like, if possible, Milan, to keep for 7 minutes, if possible, so we have also some time for question and answers at the end. Thank you.
Of course. So, hello everyone. It is my pleasure to present our efforts to implement the common information model, to standardize the data exchanges, and basically to push this subject forward in the interface project. Next slide, please. Yeah. So, the main goal of the interface project is actually to create a platform, as Nikos showed in the previous slide, that actually connects different markets. It connects TSOs and DSOs to exchange the data and creates strong incentive for the customers. On the right side, we see the high-level diagram of the architecture of the platform. We see the different actors. We see a number of data exchanges, and in the middle, we see the IEXA, which actually stands for Interoperable Pan-European Grid Services Architecture. As Nikos already showed in the previous presentation, it's composed of the 4 modules: TSO-DSO coordination platform, flexibility register, settlement unit, and the single interface to market. Next slide, please. And with all these modules and different participants, of course, we need a lot of data exchanges. In the interface project, we have defined 44 data exchanges, which actually cover the main data exchanges in the project and the platform. 56 data exchanges, which cover the system use cases of the different demos or a specific demo, but mainly they are overlapping. And as you can imagine, all of these data exchanges are actually on the information layer of the smart grid architecture model. So in a way, the best tool to describe them and to put them in a standard form is actually the common information model, or the SIM, which is one of the main pillars of the smart grid in the future. So the common information model actually is composed of 3 different standards, where IEC 62325 is the main standard used for data exchanges in the market. 61970-301 is actually the main standard used for modeling of the grid, simulations, and basically grid modeling. And the last standard, 61968-11, is concerned to assets and doesn't really relate to flexibility projects. And next slide, please. What is very specific about SIM is that it's actually an abstract model. And in the end, if you want to cover a specific business purpose, we need to address the SIM, take all the classes that we need, all the attributes, and actually build a specific profile for each specific purpose that we're tackling. For example, this can be scheduling, this can be merit order list, this can be capacity calculation, and basically a number of different purposes with a different profile. So naturally, we all see that this is an extra effort in the beginning of the project or in the beginning of each new task. So we need to ask ourselves, is it worth it? What are the benefits? And this is an investment in the end. So we can see that, of course, with the standard, we have unified naming, we have clear descriptions of the data and its meaning. So everyone knows in a project, whenever we use a specific term or a data set, what exactly it does, its meaning. Then we have independence from internal data representations in different vendors, in different suppliers of software, in different customers. Whenever the systems meet, they are able to talk to each other, let's say, without knowing the internal representation. And of course, we have a very good documentation which is consistent with previous documentation sets. Like we have implementation guides, dependency tables, code lists which are very specific, and in the end, the XSDs which cover the data exchange. So what are the steps to go forward and design a profile? We always have to define very well the business and system use cases. We have to establish the different roles, actors, and responsibilities that are going to be used. And with that in mind, we sit and we use the drawing board to define the sequence diagrams. With this information at hand, we need now to dig deep and look at all the business objects, all the attributes of the data that is exchanged, and prepare a very well written description of all of this in order to take this data, look into the common information model, and select all the appropriate classes and draft the profile. Of course, it's very clear that if we have exemplary data, which shows what is the magnitude of data, what is the scope, what is the resolution, the different timeframes, we are able to much better draft the profile and make it much more accurate. Here I want to make one important note for future and current Horizon 2020 projects. We tackle the same things as us, like markets, flexibility, interoperability. It's very important to follow from the very beginning the business use cases, system use cases, and all the data that is supposed to be exchanged. And because during these projects, it's very common to have constant research and to constantly try to improve them, which on one hand is very good, but then it creates a difficulty at the end to keep up with the modeling. So it's very good to start together with the teams who are developing the use cases in order to ensure a very high quality of the result of the business and system use cases and the sequence diagrams, and at the same time to achieve excellence within the time frame and the budgets of these projects. Next slide, please. So very interesting. What is the current project process? Excuse me. What is the current status of our project? So we have defined already a few roles which already extend the current harmonized role model. These roles are used to describe the flexibility register, the TSO-DSO coordination platform, and also other functions which are used within the platform. On the profile side, we have done a deep analysis of all the data exchanges that need to be done. We have already established a number of already existing profiles which can be used to cover the majority of the data exchanges. But of course, they need some modifications. For example, such profiles are the bid document, the merit order list, the activation document, and of course, the settlement documents. All of this is very good, but it doesn't cover all the necessities of the project. For example, there are completely new processes like resource qualification, which is used to register resources, update the resources, group resources. Then we have the product qualification, and also we have topological location and limits, and PTDF matrices and limits. The last two, topological location and limits and PTDF matrices and limits, are actually used to communicate between the TSOs and DSOs and the TSO-DSO coordination platform. This is a way of TSO-DSO interface in order to coordinate where a specific resource is located in the grid. Is it a TSO or DSO grid? What are the limits at that specific location to provide flexibility services? And of course, this is a work in progress. We still have a few more months to focus our efforts in order to finalize all of these profiles. And more new profiles might be needed in the future to cover this process, but it's a very good step in the direction of standardization of the qualification and network limits and topologies. So we're working hard on this subject. So with this, I conclude my presentation, and all questions are welcome. I hope I'm on time. Yeah.
Thank you, Milan, for this quick overview of what we were doing also from ENTSO-E side, actually, in relation to the use of SIM for interface project, but of course the relation also with the other projects. So keep continuing posting your questions there. We will go now into two demonstrators related to congestion management and balancing. We will start with Gabriele Comodi from Osimo. Gabriele, please go ahead. And if possible, before we go to this, so I will try to take 5 minutes from the coffee break to address the questions. So, okay. Gabriele.
Good morning, everyone. Thank you, Norella, for introducing me. So I am Gabriele Comodi from Università Politecnica delle Marche, and I am the demo leader of DSO and Consumers Alliance. Next slides, please. So the goal of our demo is to demonstrate in a well-defined area how the coordination between flexibility service providers and system operators can improve the quality in the DSO networks. And the second goal is to understand if a flexibility market could be a viable solution in a small DSO system, or if there is a minimum size below which maybe some other instruments like incentive must be taught. Next slide, please. So going in to present the demo of Osimo is a multi-energy island, multi-energy mini-grid with just one point of common coupling with the national TSO and with 37 megawatt of distributed generation installed all over the network. And apart from 1.2 megawatt of cogeneration plant connected to a district heating network, the remaining capacity is from renewable energies, so mainly hydro, biogas, and PVs. We have also smart meters at all final users in the district heating network, in the electric networks, and in most part of the water network. Next slide, please. So the energy island operates with a high share of renewable energy. So we calculated, we monitored 26% of the annual energy demand from renewable energy. And if we include also 30% the cogeneration plant, we have the overall amount of distributed generation share on the annual energy demand is 30%. And most of the weekends all over the year are the mini grid operates in island and injected back to the national TSO energy, mainly renewable energy, with a peak that is around 19-20 megawatt for a total amount of energy injected back to the grid of about 44 gigawatt hours, most of it from renewable energy. Next slide, please. So the concept of our demo is that in our demo we have 4 flexibility service providers. They are 3 aggregators that operate in central Italy and having flexibility resources installed in the DSO network. And we have 1 large user that operates only in the local network, having several flexibility resources. Then we have involved also the DSO, that is the DEA, that is the local DSO. Next slide, please. So in our demo, we are going to implement several assets of several tools of the EXA platform. In particular, we are going to implement the flexibility register to register and qualify flexibility resources. We are going to develop and to use the DSO coordination platform and the settlement unit. Next slide, please. So after 2 years of project, we have some first outcomes for our demo. Under the prosumer's point of view, the first outcomes are that large users are willing to participate to flexibility markets, but we have identified some potential barriers for residential prosumers in terms of engagement, low social acceptance in energy technologies, and in the amount of flexibility that can be achieved by the residential prosumers. In this sense, we are investigating also incentives, because now in Italy is starting some incentives on local energy communities and collective self-consumption. So we want to investigate also if this incentive mechanism could be a viable solution. Under the DSO point of view, we have seen that at the moment, with concern the small DSO, it can act more like a super partners facilitator for global ancillary service rather than to a purchaser of them. And we have identified some potential barriers in terms of local regulation. Finally, with regard to the IEXA platform, we see that flexibility register and TSO-DSO coordination platform could be very useful tool to manage in advance congestion management in the medium voltage and low voltage networks. So that's all from my side. I hope to be on the time, and then I leave the floor.
Thank you very much, Gabriele. Yeah, you were very much in time. Thank you for that. So we move directly now to Dagmar from Elering, so the TSO in Estonia, talking about the single flexibility platform and the integration into IEXA and interface. Dagmar.
Hello, everybody. This is Dagmar Ilp from Elering. I'm Finnish Baltic Timo lead. Next slide, please. Finnish Baltic Timo parties include regional TSOs and DSOs. As an objective of Interface is closer cooperation with TSOs and DSOs, leading to a more reliable network as well as lower grid management costs. Other participants are R&D parties, energy and IT service companies, and parties not only from our region, but from other countries of Europe, including ENTSO-E and European Tonomics, as the aim is to have a common pan-European perspective and alignment. Next slide, please. Finnish Baltic Timo will exploit interoperable pan-European grid service architecture as flexibility services platform, which was already introduced today by Nikos from European Tonomics. Therefore, I will focus on the goals to be achieved in the near future. And as also Nikos said, the aim is that we will start with early piloting within next weeks, and therefore more news will come hopefully already in the near future to everybody. Protocols include to develop regional solutions for involving consumption and production-based flexibility for power markets as existing electricity markets in order to also meet requirements of clean energy package. Decarbonization is a priority for the European system now and in the next years. For this purpose, also stronger engagement of consumers is needed, more flexibility services for distribution and the transmission grids, higher level of regional cooperation as cooperation between a group of neighboring countries, as well functioning reserve, retail and wholesale markets. Also, there is a strategic goal in the Baltic stage, which is desyncretizing from the Russian power system, which means for us that the flexibility service platform piloting is a very strategic goal in this region. Next slide, please. So as said, the TIMO will serve as a first prototype of a common pan-European architecture that connects market platforms, linking wholesale, retail, balancing, and new congestion management markets. We have brought out here some of our core aims. The first one is the focus on flexibility service providers, demand-side flexibility, and distributed energy resources to participate in flexibility markets. The aim is to standardize different pre-qualification processes and to combine MFRR and new congestion management products. Emphasis here has been given also on cross-border exchange of aggregated flexibility for MFRR, and this is not a developed area yet. And we see that the cross-border flexibility platform can be a unique solution also for other countries in Europe and in our region. Also, the aim is to digitalize settlement processes of flexibility activation, which EEXA framework will provide. And it will also ease participation from flexibility service provider side. The second very strategical aim is to increase coordination between DSOs and ESOs to enable higher participation of flexibility. And this is one of the key requirement also of clean energy package. And our regional TIMO has put a great focus on working on TSO coordination mechanisms, which means that the platform will incorporate direct activation and coordination mechanisms between TSO and TSO to ensure flexibility bids won't cause congestion in TSO and TSO grid, and allow also higher participation of flexibility, which will result that system operators will save on network investments from new congestion management products, but as well the aim is to increase liquidity of existing balancing markets and new flexibility markets in that sense. The aim is also to facilitate competition between power exchanges, which is our third strategic aim here, because competing market platforms should participate, and for that EEXA will provide a single market interface. And the strategic aim is here to secure competition and the supply of flexibility at the most competitive price. And for that, also the aim is to use locational bids for market parties to be used for congestion management by DSOs and TSOs, and that could access via wholesale markets. And this is it from my side. Thank you.
Thank you very much, Dagmar, for being very brief and giving insight directly into our Nordic demo. So I will take a few more minutes from your coffee break. I apologize for this. Before we go to the next session, where we will have inputs from other projects, which are in a way sisters or brothers with Interface. So I will go now directly to the questions which were raised in Slido. The first one is related to the use of APIs from distributed energy resources, and actually how we can take advantage of this across the various demos. I think this is a question for Nikos. Nikos, if you can briefly answer this question, or George?
Yes, Norella, thank you. So basically, the focus of the EEXA is a bit on a higher level, because we are examining the interactions of the FSP with the market and with the system operator. So we're not focusing so much on how the FSP manages the portfolio and how the communication with the respective distributed resources is achieved between the FSP and the actual resource. So this is not in one of the main names of the project to standardize the API communications between individual resources, at least at the EXA level, at the platform level. So possibly some demos are trying to achieve this, maybe also in the case of Osimo, which was presented by Gabriele earlier, but the EXA starts at a higher level than this.
Thank you, Nikos. We go now to another set of questions. Pierre, please come in. So this is more related to the markets and the products. One of the question is actually how in our analysis we cover the end consumers and the self-generation, as well as the upcoming of the microgrids, if we consider this.
Yes, thank you for the question. Both of it, of course, was taken into account. So especially end consumer level was taken into account in the analysis. What we figured out, and especially in correlation with the demonstrators, is of course that as soon as we use individual flexibilities on microgrid, so on end consumer level, the impact on congestions, of course, in higher voltage levels is always limited. So if we are speaking about transmission system operators and the transmission systems, of course, individual flexibilities, or the impact of individual flexibilities is always limited, and they need to be aggregated. We took into account, or we figured out different ways how to aggregate them and how we can use different regions basically to accumulate flexibilities in these regions for higher grid levels. The second question regarding microgrids. Yes, microgrids have been taken into account, especially in the demonstrators focusing on peer-to-peer markets. There we are really speaking about small consumers trading electricity amongst each others. One of them is taking into account congestion management issues by dynamic network tariffs here as well. So that is one possibility that we foresee here to ensure a stable grid. I hope that answers the question.
Yeah, thank you. We go ahead very briefly. If you can explain the difference between combined market and integrated market in interface, yes, but very briefly, yeah.
Yes, I give my very best. Main difference is that we are always focusing on the merit order list and the question where there is one merit order list where both TSO and DSO or different markets can have the same access to, or whether there are subsets of the merit order list. So basically, the DSO can accumulate flexibilities from a subset of the TSO's flexibility bits, or the other way around. So that is the main difference. So subset of a merit order list which is available to one of the partners, or the whole merit order list is divided, or the whole merit order list is available for both.
Okay, thank you very much, Pierre. The last two questions, I don't know if I will have the time to take. Milan, immediately, IEC 61850, if it's considering the demand response control interactions.
Actually, it's not considered because it's not the purpose of the project. The project is focused on creating a common platform in the middle of all participants, and not on operation and activation of these resources individually. So not the interest of the project exactly.
Okay, thank you very much. And then USEF flexibility trading protocol. I don't know if I'm correct on this. Maybe Dagmar can answer that. I suppose that it's the example in Netherlands, but I'm not sure. Dagmar?
Could you please repeat the question?
USEF platform.
Okay, so in terms of USEF framework. Okay, so I can very shortly answer, but perhaps George can say more. So user framework, indeed, it is from the Netherlands. But George, would you like to support me?
Yes, I think that I have conducted my survey, let's say, regarding USEF in the past. So if I remember correct, it has to do with central marketplace for bid placing. So this is not, this has not been considered as part of the interface, as this is not within, let's say, the scope of interface. So we do not enter, let's say, the operational details of the markets that match. Our, let's say, scope is to collect the bids from different marketplaces to allow FSPs to place their bids separately in all of these markets, and then to take all this information and facilitate the bid qualification, and also inform the operators and present the market order lists for the coordinated action. So it's not within the scope to have a central marketplace. We take the information from many different marketplaces.
Thank you very much, George, for this answer. So with this, we close the first part of this webinar. I would like to thank all the panelists, so the representatives of the European Commission, Sabine, Julia, and Andrea. I would like to also thank Athanasios for joining us from his position now as president of NRA in Greece. As well as my colleagues in Interface project, George, Nikos, Dagmar, Gabriele, Pierre. If I forgot somebody, I hope not, and Milan, so my team member, as well as those who are behind this organization, so Laurent and Carlotta. So thank you very much. I think we eat quite a lot of time. If you allow us to start at 11:35, so you can enjoy at least 7 minutes of break. Thank you very much.
So, hello again. I hope that you did find some time to have coffee. I think we're about to start. So I would like to now welcome you to the second session of the 2 days Interface Project webinar. This session I find it very interesting because in the Interface Project is not, of course, working on its own, but it is a member of a larger family, of a larger cluster of projects that are under the BRIDGE initiative of the European Commission, working together towards interoperability, standardization, and other aspects. So, therefore, we have some representatives from BRIDGE, but also some representatives from sister, let's say, projects of Interface, namely Coordinate and OneNet, that have been awarded a contract under the same call as Interface, and also EU SysFlex. All these projects deal, of course, with the coordinated use of flexibilities, and also the integration of large-scale resources, and also with the challenge of coordinated actions of TSOs, DSOs, and consumers. So, as a first presentation, as a first presenter, I would like to invite Mr. Ercole De Luca, who is the head of electrical system development at RFP, and also the coordinator of the BRIDGE regulation task force on the harmonized electricity market role model. So, Ercole, please go ahead.
Thank you very much, dear George. I hope you can hear me.
Yes, perfect.
Hello. Okay. Thank you, George. Yes, we have been. Good morning, everybody. We have been working on this harmonized electricity market role model action that was launched by BRIDGE, cooperating a lot with several projects. First of all, with Interface. So we are grateful to Interface and to George in particular for the support given to us. I will try to be very brief in order to recover the time that we had, since we were supposed to start 10 minutes ago. I don't want to stress you too much. What's the HAMR community? As we said, I have been the action leader together with the Platone project management team. And we had in the first part of this job as contributors a group of first selected projects that gave their availability to start on the first part of the differential analysis between the actual HAMR that is held by ENTSO-E, EBIX, and EFET. And in between, you see all the project, Coordinate, USysFlex, Favor, GoFlex, Interface, and then, of course, Platone. What happened in this first moment? What we asked to this first selected project, we said, okay, we have an HAMR that is owned by, as we said, ENTSO-E, EFET, and EBIX. Probably it needs to be a little bit modified or integrated, looking at what BRIDGE project like the ones listed here and all the others in the BRIDGE program are working on. We are developing a lot of new concepts in flexibility, focusing on flexibility, interaction between TSO and DSO, platform and data, and so on. So that we said, let's put together our first ideas and make not a new harmonized electricity market role model, but a differential analysis between what we see from BRIDGE projects, Interface, Platone, and so on in first place, and then we involved all the other. What we see would be good to integrate in the actual model in order to have a complete picture and start a discussion with the ENTSO-E, EBICS and EFET, and try to start together saying, okay, we have collected as bridge project this point of view. We see some differences, we see some needs of new roles. Please, this is our work. So next slide, please. As you see, we had this structure, and the focus of our action was to provide a new harmonized definition of market roles, taking into consideration what is coming out from flexibility, TSO-DSO cooperation. Next slide, please. This is the story. In April 2020, Bridge assigned to the Platone project management team the leading of this action that I was coordinating. Then in June, the first selected project that I listed and you see at the bottom of the overhead, in between there is of course interface, started working on the existing ENTSO-E, EBICS, EFET, EMREM, trying to see the differences between what is there and what is coming out from our project. In July, we put together all this definition. We made a first draft of the differential analysis. And in August, we started with this interaction with all the other bridge project that was interested to cooperate. It's very important to say that not only the regulation working group of bridge was in, but we included also the data management working group of the bridge program. The coordinator was Kalle Cook. He gave a big help to us, and so that next slide, and so that we arrived in December, end of December, closing this differential analysis, and we sent it to the Commission for the approval. We are waiting now for the approval of this, let's say, differential analysis. After that, we will be able to, we will have a base to start an open discussion with ENTSO-E and all the other stakeholders and try to work together for a while until we will arrive to a definitive new model that, of course, this our document is for sure a milestone because it's a view, is a first view from the innovation project of the bridge program. Next slide, please. As you see, what we have done is we have analyzed more than 40 roles in the existing model, and we proposed around 10 integration to the existing roles. Then we added 20 new roles. We have identified them and described, because what we see, many of them come from interface, there is a need of definition of new roles. Please, next slide. I just want to show you an example of the differential analysis. You see there is on the first column, you have the role, the description, and where we have a new, let's say, an integration or a modification from a regulation point of view, it has been signed in red. So you see this red line. Where you have instead integration coming from data management working group, they will be stated in blue. For example, if you go in the next slide, until we don't find a blue one, another one, please. Yes, if you look at this, for example, energy service company, we have some integration made from a data management point of view in blue, and some others in red coming from the regulation point of view. What is important is the last column, example factors. This is something new. We have been working a lot on this. We are not only saying what is the role, we are also proposing example factors. That means in the innovation project, we have seen that several stakeholders could take that role, and they are studied in the last column on the right, example factors. Now, if you go down 7 slides, please. Again, another one, please, and another one. And now here, thank you, we arrive to this second section. Of course, this document is on the bridge repository. It's shareable, and we have distributed to all the involved projects. So interface as it. Georg was working on that, so it's available. I don't go in details. What I just want to show is that now we have seen that there are several new roles to be added, and we have also stated the projects that are proposing these new roles, so that everybody knows that from, for example, in the U6 Flex project, we have a new role named Authentication Service Provider that comes from mainly from a data management point of view and can be done from a third party. The same from customer portal operators and the others. Now, if you go one slide ahead, another one, please, because I want to show you the interface. Okay, stop here, please. Between the new roles, we have also studied DSO and TSO. Probably you say, how can it be a new role? But let's say, since in the existing ENTSO-E role, it is very, let's say, general. Never you see mentioned specifically what the DSO should be or what the TSO should be. We decided together, DSOs and TSOs, to have this general definition that, as you see, is in red, so it comes from a regulation point of view, where we state the most general possible role of a DSO, that is the one interacting with the TSO, taking care of network from a certain voltage down and so on. And we made the same from TSO. Another slide, please. Interface, if you see, for example, this is specific for interface, that said this flexibility register operator role can be done by a TSO, a DSO, or a third party. That means that we see interface, and of course we shared, we reported here, the need of a new role, somebody taking care of the flexibility register. This flexibility register put together all the action and so on related to flexibility, and up to us could be a third party or a TSO or DSO according to specific let's say, needs or member state peculiarities. If we go ahead, another slide, please. And another one. For here, what I show here, we had a lot of discussion about sub-DSO, a sub-meter data hub operator. They are specific role foreseen in GoFlex and Coordinate for sub-DSO. That means you have in a DSO framework a sub-DSO taking care of a part of this. A lot of discussion, but what we decided to say, okay, let's state here, this is a document for discussion, so let's leave it here. And the same sub-meter data operator. Sub-meter data operator means when you have the official, let's say, meter, and then you have sub-meters, probably since those sub-meters can be useful for flexibility and so on, we should look at the specific role, and we stated here. As I repeat, this is a base for discussion, but this is a new role. And then, please. TSO, as I said, trying to have it as much as possible open and wide, please. And interface, we close with interface because you are the owner of the home. The last one is this role, TSO, DSO coordination platform operator. In interfaces, foreseen to have this coordination platform, somebody probably could manage, that can be different from a DSO or a TSO. So we studied all of them. So next slide, please. Here you have a major, let's say, the only picture we have really inserted in our HEMRM, just a picture saying we have seen some new important roles. We have listed on the left, we have put in the graph on the right, saying probably those strategic role could be added. We have 7 other one. We didn't went for a new flow for the flexibility market role model because it's too early for us. This is a base of discussion. We'll discuss it with ENTSO-E, EBIX, and EFET, and after that we'll come out with the new graph. Up to now, we are just indicating on the existing graph the new roles where they could, some of the new roles where they could be inserted in. Next slide, please. Next steps. We have submitted the HEMEM to the European Commission for approval, waiting for this. Could arrive in these days. After that, we would like to start an open cooperation. All the projects that want to participate will be very welcome. Start discussing with ENTSO-E, EBIX, EFET all together to find our, let's say, comprehensive, final, harmonized model of our market, focusing on flexibility. That's all for me. I hope I was fast enough.
Thank you, Nicole. Indeed, you were fast enough. Thank you for this. And also thank you for the interesting work and analysis that you have conducted in the harmonized definition of the electricity market roles. And also we were very happy to contribute according to your instructions, let's say. So I see that you
made a lot, Jorgen. You made a lot. You worked a lot on that. Thank you.
Thank you. So I see that we have a couple of questions, but we can take these questions at the end. So I would like now to invite to enter, let's say, the Horizon 2020 projects zone, and to invite Mr. Carlos Medina. Carlos is a research engineer at Tecnalia and is here today to represent the Coordinate project, the sister project of Interface. So, Carlos.
Okay, thank you, George. Yes, I will give you a brief description of Coordinate, the project as a whole, and also entering in some details in the work we are doing in the work package that I'm leading, in which we aim at identifying the information exchanges among the different participants in the procurement of the system services. So next slide, please. First, I would like to present you the project. Coordinate is, as we heard different times today, is a sister or brother or twin project of Coordinate, as it is. It was approved under the same call. Both projects started in January 2019. We will finish a bit earlier, so we will be finishing our project by mid next year. Our budget and funding is also slightly lower than the one of Interface, and we have 23 partners plus 10 linked third parties. As you can see on the picture on the right-hand side of the picture of the slide, we have 3 demo areas in Spain, Sweden, and Greece, where most of the parties are located, but also we have representatives of the central strip of Europe. And the objectives of the project are also quite similar to Interface, since we aim at demonstrating the activation and provision of services through a TSO-DSO coordination, to define and test the standard products that provide services to the network operators, and to develop a TSO-DSO consumer collaboration platform in order to pave the way for the interoperable development of a pan-European market. And I will focus more on this last objective later on. So next slide, please. In our project, we took this approach so that we consider that the flexibility platform will be the interface that will allow TSOs and DSOs to ask for flexibilities to solve the needs that they may have at system level in the case of the TSO, or at local level in the case of the DSO, and where consumers, prosumers, aggregators, and other flexibility providers will put their bids to offer that flexibility and to solve the needs by TSOs and DSOs. And for that, we started with with setting up the framework, let's say, by identifying the coordination schemes. We will assess through simulations and also from the results of the demonstration projects, which seem to be the most valuable coordination schemes. For procuring different grid services, we identified different types of services, timeframes, and customers providing the service, so that you can see there the list of the standardized products that we define in the project. Although not all of them will be taken into the demonstration projects. As you can see in the next slide, okay, not next step, but next one. So in this one, you can see the analysis we made for identifying the coordination schemes. We defined 4 dimensions in which we look at the different alternatives that could be considered, and also the most logical ones after one of those dimensions have been set. So that the first one is to identify where the need is located in the system. It can be a central need, it can be a local need, or it can be a central and local need that needs to be solved at the same time. The second dimension is who is the primary buyer of the flexibility. So in the case of the central need, it will always be the TSO. In the case of the local need, it will be the DSO, but it can also be peers. And in case of central and local needs, it would be TSOs and DSOs, but also external stakeholders can be considered in the same market as the other 2 agents. And of course, also peers. The third dimension is how many markets are used to buy flexibility. So flexibility can be bought in only one single market or in more than one markets. And in this sense, I understand that this is very much related to one of the latest questions in the morning session, according to the difference between the defined market models and whether the market is considering a single merit order list or more than one merit order list. And the final dimension is whether the TSO has access to the flexibility located in the assets connected to the distribution level. So depending on whether they have access or not, we also define different coordination schemes. And you can see in the bottom side of the slide, the 7 coordination schemes that we defined, the central, the common, multi-level, fragmented, integrated, distributed, and local, depending on the choices that we made for those 4 dimensions before. And then we took these market models and brought them into the demos. As we can see in the next slide, here you can see that we defined 4 standard services out of the 7 that we identified in the conceptual framework. We took into the demos 4 of them: balancing, congestion management, control islanding, and voltage control. We defined different time frames from long-term up to near real time, with the different coordination schemes that we have just seen, and with different product types, or capacity or energy products, and being provided by different flexibility providers. The slide has a lot of information, but you can see depicted in pink what will be tested in the Spanish demo, in yellow what will be tested in the Swedish demo, and in gray what will be tested in the Greek demo. As you can see, in each of the demos, we will demonstrate at least one service with 2 different coordination schemes. In the case of Sweden, we will be testing balancing with local and multi-level market models. In the case of Spain, we will be using local and common market models for solving congestion management. And in the case of Greece, we will be using multi-level and fragmented market models to solve both congestion management and voltage control. Now moving to next slide. You can see here the phases of the project. So first we did that conceptual framework, mostly in the first half year of the project. And then we started all the works to do the implementation in the different demonstrators. In fact, the 3 demonstrators are planned in 2 demo runs. The first demo run for Sweden already took place last winter, and now we are performing the first demo run for Greece and Spain, and the second demo run for Sweden. Then once we finish all of them, we will collect the results from the demos and extract the final results and conclusions of the project. And next slide, please. Here, this slide shows you let's say the architecture that we defined for the exchanges of information at theoretical level for the different actors. So we defined 3 main blocks: the grid monitoring and operation block, the aggregation and disaggregation block, and the market operation block. In the first of them, TSOs and DSOs, by doing rest forecasting, load forecasting, state estimation, and so on, identify the needs that they will have and that will be solved through the use of flexibility. They communicate those needs to the market operation block through what we call the coordinate platform. In parallel, the aggregation and disaggregation block checks the real-time status of the units providing the flexibility and create the bits to be sent to the market, which are again sent through the coordinate platform. The market operation block would then clear the market, communicate the results to the other 2 blocks, and then the aggregation block would dispatch the units according to the results of the market, and the TSOs and DSOs would check the real-time performance of those units. Our aim is to standardize the interfaces on the right-hand side of the slide. So everything that goes through that coordinate platform, which may not be a single platform, but all the platforms that could be implemented should be interoperable through the standardization of these interfaces. And on the contrary, we will not try to standardize the activations of the units, which I also understood is the case for interface in one of the last questions in the morning, and also how TSOs and DSOs check the real-time performance of the FSPs. As you can see here, this is the theoretical long-term view, but in coordinate, the approach we took is that in parallel to this definition of how the future would look like, we already started as soon as possible the implementation into the demos, so that we started from the existing platforms and made the required updates so that we could start the demos. And in parallel, identified the requirements of the demos to also feed this discussion on the long-term view. Next slide, please. As you can see here, we started identifying the business use cases and the demo needs. With those needs, we identified the functionalities that the different tools should have. And in this case, you can see some examples of the functionalities we identified for the grid operation and monitoring block in black, the functional and data functionalities, operational functionalities. Then some functionalities for the market operation block in blue, prequalification, bid filtering, market clearance, settlement, and some other functionalities for the aggregation and disaggregation block, market bidding, price models, DR models, weather models, and so on. and then some other functionalities which could be common to all the blocks, like security and the ability to communicate with other blocks. With these tool functionalities, we identified the tools that are being used by the demos or that could be used to meet those functionalities, which are the ones represented in the left-hand side of the slide. And with that, we identified the requirements that those tools should meet. In a way to say, the functionalities are the objectives that the tools must meet, and the requirements are the performance of the tools, how the tools meet the functionalities. For that, we used a Moscow prioritization methodology, so that to each of the requirements we give a priority from 5 to 1, according to whether the requirement is something that is a must-have, is something that should have, is something that could have, or that won't be considered in this case. Next slide, please. And with this identification of the requirement of the different tools, we identified the exchanges of information that must take place through the Coordinate platform, and we created a service catalog where we put all this information. Within this catalog, we see how the stakeholders exchange information, what role the Coordinate platform plays, and how the platform is integrated into the information flow between DSOs, TSOs, and other market players. And in addition to this catalog, we also identified the required standards, the common interfaces, and the requirements for the information exchange. This catalog has already been published in one of the deliverables, and through this year we will be in close cooperation with the demonstration pilots to identify any other additional requirements that that was not foreseen before the start of the first demo runs. And also we will update this catalog based on different dimensions. We may also include the KPIs, the technology readiness level, the quality level, access rights, and some other dimensions. And next slide. And you can see here in the Coordinate website, in the deliverables page, the 4 deliverables of Work Package 2. So the one describing the market operation block, the one describing the grid operation and monitoring block, the one describing the aggregation and disaggregation block, and the one with the service catalog are freely available and can be downloaded from the website. And also included in Work Package 2, we are also preparing another report about game changer technologies to promote the participation of consumers in these markets, which will focus on the blockchain technology and its use in the Swedish demonstration. So I'm done with this.
Okay, thank you, Carlos. And we'll need to move forward fast and go to Mr. John Lowry, the project manager at AirGrid, but also the project coordinator of the EU SysFlex project. So I would like to kindly ask John to perhaps keep the 10 minutes slot, or even perhaps 9 minutes, so that we can still have 2-3 minutes at the end for questions. So, John, please.
Good morning, ladies and gentlemen, and yeah, I'll try and keep this as brief as possible. My intent this morning is just to try and give you a flavour of the EU SysFlex project and an update of where we are, given that we're 3 years now into this and into our final year. So it's really about bringing the outputs of the project and more importantly the impact to bear. So maybe we could just slide on to the next slide, please. And this is really just context, I suppose, of where we are today in terms of variable renewables and where we need to be by 2030 and beyond. And I think it's indicative of, you know, what's happening in Ireland in terms of our the variable source of renewables. That is a very large percentage. We recently actually hit a record of 70% system non-synchronous penetration there just on Tuesday last, which we're all very proud of, and that's due to a lot of the work that we're doing in terms of integration of renewables in Ireland. So this is a broader context of the European story. So maybe we'll move on to the next slide. So not only are we talking about that integration of high levels of variable technology, there's also other system complexity that we're trying to address within EU Sysflex. The large deployment of battery storage, which I think we're all aware of, enhanced interconnection, the decentralized and distributed nature of where the system is actually going, increased system demand, demand side participation, congestion, electrification, and obviously less inertia as a result of the changing dynamic to renewables. So we move on to the next slide. So just our consortium, just to give you an idea of EU Sysflex, it's a very broad consortium made up of TSOs, DSOs, technology providers, generation and retail, as well as research institutes and universities right across Europe. It's a consortium of 34 members across 15 different jurisdictions in Europe. This is supported by a strong advisory. Maybe we move on to the next slide, which consists of representative groups such as ENTSO-E and a large body of TSOs and DSOs. So we move on. Just get into some of the more technical issues of the project. So what is the EU Sysflex project trying to achieve? Well, ultimately what we want to do is create a roadmap to address the future operational system complexities, which we're starting to build now. So it's really bringing the outcome of the project together. And this is really the core dimensions of the project. So it's identifying the system scarcities associated with a very high renewable environment. We're coming to the conclusion of some of that work, and I'll be able to give you an update on it. We're also looking at market and regulatory dimensions which are completed. It's about recommendation of augmentation, incentivization that we required for the right type of flexibility and system services. We are also looking at flexible capability of plant, particularly through our demonstration projects and trials. And obviously then the support tools to procedures and policies around that to support a system operation in a very high res environment. And then finally, but not least, is the scalability and replicability of our solutions. So we can move on. So you can flick through this slide because I think it's an animated slide. So maybe if we just get to the end of it, like the approach here is very much a bottom up and top down approach, looking at it from this very broad system needs perspective on a pan-European basis, looking at it on an Ireland, Northern Ireland basis, continental Europe and Nordic regions, the market and regulatory enhancements, as I said, the cross-border data exchange. And then from a bottom up, it's very much the technology, the demonstration projects, the portfolio of services that are required to deliver the change that is needed on the system. So we move on to our next slide. So the project also consists, maybe you can flick to the next, I think there's an animation here as well. So the project consists of a number of demonstration projects. We just go back. And trials in Ireland and Northern Ireland. So this is looking at different dimensions of aggregation of services. It's of the data management and the technology capability provide services to grid, as well as the trials that are happening in Ireland and Northern Ireland. So this is real-time capability. It's real-time procured services to trial solutions on the Irish grid. Okay, we can move on. So some of the key outcomes. So this is in relation to the system scarcities on the system. So we're concluding a lot of the technical analysis. I'm currently working on a task 2.6, which is about identifying the solutions to these scarcities. So what are we identifying? So it's broken up into three different areas, because they're slightly different in terms of the broad European and continental system, the Northern Ireland system, and the Nordic region. So you can see, given the penetration of renewables in Ireland, the requirement is quite advanced, and therefore the scarcities are quite advanced also. In terms of the continental Europe and Nordic region, there are evolving characteristics and some concerns. Also, so what we're talking about here is balancing and stability issues at high res and system non-synchronous penetration. They're experienced in the less interconnected areas across Europe, and are appearing in continental Europe at 60% res and above, especially in cases of system split. Congestion in all grid areas, as well as cross-border unscheduled flows, and the need for inter-system operation coordination and TSO and DSO coordination. I think what I'd like to focus on here, or bring your attention to, really is our webinars. So we have a number of webinars on our website, which are really focused very much in the detail behind the conclusions of the next three slides that I'm going to show you. And I would highly recommend that you visit our website and watch our recorded webinars to find out the technical detail behind all of this. They're actually very, very interesting webinars. So I've a few minutes to talk about it here, but if you want more detail, I would go there. They're very interesting. Next slide. So not only were we looking at the technical scarcities and solutions, but the challenges are also of a financial perspective, and the need to incentivize investment to ensure that we deliver our 50% renewables. So what we are identifying is, in terms of the investment cost structure is changing, the variable costs are decreasing, there's a downward trajectory on energy market prices, and in future scenarios due to increased levels of res, and the energy revenues are falling. So there's clear evidence that an additional revenue stream is needed to sustain a reasonable return for investment. So if we just flick onto the next slide, you'll see that this gap we're identifying can be filled by a system services market. So again, there is a very detailed webinar on our website addressing the financial gaps and challenges around the market changes. So we move on. So the market design evolution. So this was part of work package 3, which is now complete. And the I suppose the recommendations and outcomes of that is the change in the power systems imply that more flexibility from remaining conventionals is required, and that new flexibility providers need to be introduced into the market. New services are definitely needed: fast frequency reserves, larger volumes of reserves, shared across countries, and much closer to real time. To include generation and flexibilities embedded in the distribution system, and optimize local and global operation. And coordination is crucial between system operators. Services could be needed and also provided at DSO level, and processes and roles will need to be re-evaluated. Investment in new generation and new flexibilities, but also in network reinforcements and new different type of components to address the system scarcities are needed, and as soon as possible by clear and stable market signals. So again, I would recommend you go and visit our website to look at that detailed webinar on the market recommendations and findings. Okay, we'll move on. So the demonstrations, maybe you might just flick on one more slide just to bring the whole slide into play. So the demonstrations have been grouped into three sets of solutions, really. The aggregation of decentralized sources, the accessing of distributed flexibilities, and overcoming digitalization challenges, which are all very, very important. So this is, I suppose, is the demonstration of the capability, the technical capability and operational capability that is required to meet the flexibility requirements. So we move on. So finally, what the aim of this is to bring all of this together into a roadmap of change, addressing that system and market requirement, the data management and exchange requirements, our operator protocols and tools, and breaking barriers to renewable integration. So we're talking about here is the technical, economic, and regulatory challenges have been confirmed by our simulations. And the final analysis in terms of further flexibility capacities is underway. The field tests to validate solutions demonstrated and their potential for the system. The identification of that will be concluded this year, as well as the data management, flexibility and digitalization challenges. The results from that will be out this year. And the scalability, replicability, and reliability will all be brought together in our final roadmap to encompass all results and share our key findings and outcomes of the project. So we can move on then. So I'd just like to thank you for listening to me in this very brief presentation. As I said, what I would recommend is you go to our website and check out our webinars for much more detail, and you'll have a lot more time to take in exactly what this project is about and its value add and its impact. So thank you.
Thank you, John. Indeed, this is very interesting, and the EU's Flex has many, let's say, novel things to show, to present. Thank you for trying to bring all this in one short presentation. And now I will need to move as we're running out of time. So I would like to invite Professor Antonello Monti, a professor at the Institute for Automation and Complex Power Systems at RWTH Aachen, and also the project coordinator of the recently kicked off OneNet project. So Anto, according to the schedule, we have 5 more minutes. Of course, you can take perhaps 8 minutes and perhaps have 2 more minutes for questions. Thank you.
Can you hear me okay, first of all? Is the audio okay?
Yes, yes.
Can you hear me? Perfect.
Yes.
Thank you very much, George, and I'll try to stay in my slot. Yeah, let's skip directly to the next slide to start talking directly about the project, please. So OneNet vision is really to bring together all the efforts you have heard today. So we come at the end of this section, it makes sense because basically the goal of OneNet is really to bring the experience of all the projects you heard so far, key partners for all the projects you heard today, starting obviously from Interface, but also Coordinate, USys Flex, and also Platone was mentioned by Ercole, are building the knowledge that we want to harmonize and bring together so to have a whole European electrical system to operate as a single system. That's what OneNet means. And we want to do this in a variety of markets and enabling a universal participation of stakeholders. We are being funded in the same call of the Interface and the same topic, sorry, but in the next call that was 2 years later. So we are the young, let me say, brother of the other project. We have been running for only 5 months. And next slide, please. I will give you briefly about these key points of the project, the knowledge base, the demo clusters, the structure of the consortium, and very important, which is one activity that is already ramping up right now, is the concept of the GRIPHON Forum. So next slide, please. As knowledge base, so we have been funding the TSO DSO Customer Cooperation Fund, and we have then bring together a large base of knowledge. This is the key point, and addressing then the same challenges you heard from Interface and OneNet. And the idea fundamental is that we are not trying to bring that in the sense to create a single solution, so a single platform, but actually to enable the cooperation among different platform and solutions so that the full knowledge of projects like coordinated interface can be brought into a general view and picture that we call OneNet. Next, please. A very important part of the project, and that's why we have also so many partners, is the implementation of everything we develop in real life with very large demo clusters. So the idea is, in the other project, we already built some large significant experience of demonstrations. Here we try to do a one step further in terms of scaling up. And what is the key motive of our demonstration is what in the proposal we have been calling the multi-multi idea. So in the view of the demos, of actually what we call clusters of demos, is that every cluster must include more than one DSO and more than one TSO, so that all the possibility of combination are possible in our scenarios. And then you organize those in clusters. So you see the Western cluster is covering the France, Spain, and Portugal. Then we have the Northern cluster, which basically cover the whole Scandinavian countries. And then the Eastern cluster covers a good part of the countries in the eastern part of Europe. And last but not least, we have the Southern cluster that is going to Greece and Cyprus to cover the south part of Europe. And that's the way in which the new market concepts are also tested in the real life. Next slide, please. Talking about the consortium, we are the biggest of all these consortium because we have 73 partners. What is very interesting is that we have among partners both EDSO and ENTSO-E, which means both associations will be directly involved in the discussions. We have a large set, consequently also TSO and DSO. Think about all the countries that you've seen involved. And we have leading IT companies that are involved in the consortium, together also with renowned research institutions. So, for example, European Dynamics, which is coordinator here, is also one of our key partners. And also we have, for example, also engineering and UbiTech on top. They bring other components of knowledge to the system. Next slide, please. Yeah, one key message for me at the moment, of course, we are a very young project for the moment. A lot of work has been done in bringing this experience together. For example, associating the use cases from the different projects, sorting them out, and understanding all the requirements coming from all the possible business and then technical use cases. But what is for us a key message from the OneNet project is that we want to be a really, really open project. And this will be a reality in two directions in the project. Once because as other projects will have cascading funds, but the other important point is the creation of a forum, which is called GRIPHON, stands for Great Forum. And the idea is to have a mechanism of inclusion for every possible stakeholder in Europe. We are reaching out to basically everybody. Whoever is in the call and is interested, please check on our website for updates. We are developing a set of mechanisms to get the involvement of every stakeholder in Europe. Why is that? Well, because while we bring this picture together from the several projects I mentioned, and we create this global picture, we want to build consensus around the solution we propose. And for that, we want to involve every stakeholder in Europe in the discussion from the beginning, so that once we are at the end of the project, we will have some position papers that are on top of our deliverables, so are not official part of the deliverable list, but because they are an open type of documents that everybody can access and comment and so on, that we plan, we aim to have as the document which has a very large support in terms of stakeholders in Europe, so that the transition from there to any kind of reality and activation beyond the demo will be way, way shorter than any other previous project. The idea is we're lucky to come somehow at the end after all these other important projects you heard already today, and we have this mission to bring things together. And then is for us a key target of the project to build this consensus, so that it's not just a solution of the consortium, is really a European one. Next slide, and I think with this actually I am at the end. Yeah, we just launched the website, so you're welcome to go visit and learn more. And what I can tell you in 5-6 minutes today. And please, particularly, there is a link to the webpage on Griffon. Stay tuned to Griffon and learn while we start developing the offer to stay connected with us. I thank you for your attention, and I give it back to you, George.
Thank you, Anto. Indeed, I also wanted to highlight the importance, the role of Griffon. I think that it is very important if we want at some point to reach this EU-level consensus, as you mentioned. Also, we are very happy as Interface and as European Dynamics that we also are part of the knowledge base. Thank you, Anto. I think that we do not have more time. In any case, I think that I would like perhaps to take a couple of questions. I don't know, as a call, De Luca has left. I don't know if someone from ENTSO-E could take a couple of questions regarding the connection between this harmonized electricity model role model. What is the connection with the ENTSO-E work on harmonized role model framework of CGMS?
I will ask Milan to step in. Milan, you are not anymore there. Then Paulus, please.
Oh.
Okay, it seems that none of them are available, so I will try now to take the question by myself. So, of course, this is what I think it was explained also by Milan in his presentation. So there are also it's a platform actually which is developed together with EFET and so on. So the relationship between what we do in Bridge and what is done in ENTSO-E, it's actually to enhance the harmonized role model with the new features coming from all these projects you have seen today actually explained. And of course, this is going to be translated afterwards in the application of SEAM and all the sequence diagrams, what you have seen today explained by George and by Nikos, as well as by the demonstrators. So the relationship between harmonized role model activity in the Bridge is to enhance actually the harmonized role model in which ENTSO-E, EFET are involved as statutory parties.
Thank you, Norella. And I think that this was the last question that we could take. As we need now to close. I think that we can continue this interaction with all of you through the social media and the different communication channels, as you can see on the screen of the Interface project. We would be happy to have a follow-up, if you would like to send your comments or your questions directly through the website. You can find also the email addresses of different partners. So that's all for the second part of our webinar. At this point, and as we need to close with no delay, I would like to thank everyone for your attention. I would like to thank our distinguished speakers from our project officer, from the speakers, the representatives of DG Energy, also the president of NRA, the consortium members that actually provided the vision, and also our representatives from Bridge and sister projects. So thank you all. I think that it has been quite fruitful and quite interesting and important to show the context of interface and all this work, all this activity that is in progress all over Europe with all these initiatives and projects. I would like to thank the ENTSO-E team, Norella, Laurent, Milen, Paulius, and other people for the excellent organization of this webinar. And as I said, let's hope that the next webinar takes place physically, perhaps in Brussels, and we have the opportunity to meet all together and interact. So thank you, and we'll be in touch.